There has never been a way to easily and reliably locate exactly where a wire is shorted to ground. Until now. This video shows the Wire Integrity Tracing System, or WITS, from Creative Sonic Research, going beyond what current technology has been able to achieve. You're looking at 3 sections of aviation-grade electrical wire on an aluminum foil base. Aviation-grade wiring has challenging characteristics. The aluminum foil base is chassis ground for our testbed. Aviation-grade wiring on an aluminum foil base is the preliminary testbed setup recommended by the FAA Technical Center. In one of these 3 test wires, we have created a short to chassis ground to illustrate how quickly and easily our new WITS can first detect the shorted wire, and then we go beyond what current technology has been able to achieve and accurately locate exactly where the wire is shorted to ground, even with the challenging characteristics of aviation-grade wiring on aluminum foil. The Wire Integrity Tracing System from Creative Sonic Research is the first device capable of filling the wire safety industry's need for a new wiring diagnostic technology. One of our new technologies we discovered enables our tracer to trace our reference signal along the path of a wire, even if the wire is shorted to ground. Our transmitter can transmit our patent-pending reference signal through any metal core electrical wire of any useful length, even if the wire is shorted to ground. The red output lead can be connected to many different adapters for connecting to aviation and automotive wires and connectors. Our tracer is tuned to our reference signal. As the transmitter's output lead is moved closer to the receiver, the tracer's LEDs in the meter needle indicate the level of the reference signal reception: red for low level, amber for mid-level, and green for high level. The left to right deflection of the meter needle goes along with the LEDs and is useful for finer tracing techniques. To better detect and trace our transmitted reference signal, the Wire Integrity Tracer's sensitivity is adjusted to a mid-range reception level indication. As you see, our tracer's amber LED is lit and our meter needle is in the mid-range area. We feel the ideal wiring diagnostic tool should be able to detect and locate wire faults. Our WITS is used to first detect if a wire is shorted to ground before tracing the wire's path. Touching our transmitter signal lead to our chassis ground, we can see how our tracer indicates the presence of a shorted wire. The tracer indicates a high level when the transmitter signal is connecting and shorting to ground, and a mid-level when the signal is not connected to ground. We connect the transmitter lead with our first wire, and the tracer registers the normal mid-level from the transmitter's reference signal, indicating a non-shorting condition, so our first wire has passed. Our next wire registers the same mid-level, indicating this wire is also not connected to ground. Our second wire also passed. Now our final wire. You can see the meter needle deflected to its far right and all of the LEDs are lighting up, indicating this wire is definitely shorted to ground. You have just seen our WITS clearly detecting that a wire is shorted to ground. Now you will see how we use our WITS to locate exactly where along the wire it contacts ground. Detect and locate. We connect the transmitter output lead to the shorted wire and then use the tracer to follow the reference signal along the shorted wire's path. We ensure we are tracing only the wire's path by observing either the tracer's meter reading or by watching the tracer's LED level indicators as we move the tracer. When they show a reduction in reception level, we have strayed off our wire's path. See as the green and amber LEDs dim as we stray off the wire's path and get brighter as we move the tracer over the wire. When we come to a point in tracing along the wire's path where the tracer's LEDs and meter readings substantially reduce, no matter which direction we move the tracer, then we know we have arrived at the area where the wire is connected to ground. We simply use the tracer and zero down closer to the wire. When the LED level indicators and the meter needle begin to indicate a reduction in signal level, we know the location of the short is directly under the tracer. And here is our shorted wire's connection point. Just one fine strand of 22 gauge aviation grade wire touching the foil test bed caused the whole wire to be grounded. We can put some scale to this by placing a quarter next to the shorted wire strand. You can see the changes in the tracer's level indicators just in this small distance of less than 1 inch. It took the discovery of 2 new technologies to accomplish this. To make the use of these technologies even sweeter, we have an additional feature. Our wire integrity tracer can achieve the same fault location accuracy through metal and other obstructions. You can see, just as before, how easy it is to know that we are tracing our wire by observing the LEDs and meter reading as our tracer is moved over the wire path. We know we have strayed off the wire's path by the meter's decreased reading and the LED level indicators diminishing. As we move the tracer back along the path of the wire, you can see the level indicators increase, ensuring us that we are, indeed, tracing our wire. Just as before, when we get to a point where the meter reading and the LED indicators suddenly diminish, and there is no further signal to be found, then that is a spot where the wire is shorted to ground. And there is our quarter next to our shorted wire. At the FAA Technical Center, where they are heavily involved in testing new ways of wiring diagnostics, they have stated that the bar has been set. The bar they speak of is the distance between where a device indicates a wire fault exists and where the actual wire fault is located. And their highest bar, as they state, is set at 2 feet, 2 feet away from the actual location of the wire fault. You've just seen the new bar being set, less than 1 inch. This groundbreaking new technology is so sensitive that our wire integrity tracing system can also locate a complete break in a wire, called an open, as well as locate a partial break, as when some of the wire strands are broken and frayed. And we can locate these different types of wire faults with the same accuracy as you've just seen. But those are other videos. The wire integrity tracing system from the labs of Creative Sonic Research, the only technology capable of easily and reliably locating accurately where a wire is shorted to ground.